Hello students, welcome to Educate. We are going to do numericals on chapter 7 of class 12 physics. So let's start. Question 1 says a 100 ohm resistor is connected to 220 volt 50 hertz AC supply. What is the RMS value of current in the circuit? What is the net power consumed over a full cycle? So we can calculate it. Here AC circuit containing resistance only. Do you remember the case as I told you? When there is AC circuit and it contains a resistance R, in that case, what happens? So here it's given 220 volt 50 hertz, right? And value of resistance is given as 100 ohm. Our concern is to find RMS value of current, and then after that what is power consumed. So here this is RMS voltage. VRMS is given as 220 volt. IRMS will be VRMS divided by resistance. So VRMS is 220 divided by resistance is 100 ohm. So this will give 2.2 ampere. Right. Up to here there is no problem. So this is IRMS. Now power consumed. Power consumed P is equal to VRMS into IRMS. Do you remember? We have already derived the relation for this. So we can put the values. So VRMS is equal to 220 and IRMS is 2.2 ampere. So this will give 484 watt. Right? I think thing is very clear. If you have doubt why this, so let's recall it. I told you that average power is equal to VI, and VI is given by V0 sine omega t into I0 sine omega t. Right? Then V0 and I0 we keep outside, and this becomes sine square omega t. And we find average value of sine square omega t. So this gives 1 by 2. So we get V0 into I0 divided by 2, or we can write it V0 divided by root 2 times I0 divided by root 2. This gives VRMS multiplied by IRMS, right? So same concept I have used here. I think you have understood. Now let's go to next question. So question number 2. The peak voltage of an AC supply is 300 volt. What is the RMS voltage? So VRMS is equal to V0 divided by root 2. Correct? And V0 is given as 300 divided by root 2. So we can rationalize it. 300 into root 2 divided by 2. So this will become 150 into root 2. So it will come out to be around 211 volt. So 212 volt approximately. So this is VRMS value, and after that, what more is to be found? The RMS value of current in an AC circuit is 10 ampere. What is peak current? You remember the relation? VRMS is equal to this thing, and in terms of current, if you write, so you can write IRMS is equal to peak value of current divided by root 2, or we have to find out peak value. So I0 will be IRMS multiplied by root 2. So here we are given RMS value 10. So 10 multiplied by root 2, and you know the value of root 2 is 1.414. So this will give 14.14 ampere. Correct? So we have got the answers to question number 7.2. Now let's go to next question. So next question says, a 44 millihenry inductor is connected to 220 volt 50 hertz supply. Determine the RMS value of the current in the circuit. So situation is like this. This is an inductor L, and there is AC circuit. Here values are 220 volt 50 hertz, and L is 44 millihenry. Milli means 10 power minus 3 Henry, right? And we have to find out the RMS value of current. This is RMS voltage. So first of all, we have to find out inductive reactance. So XL is given by 2 pi FL, 2 into 3.14 into frequency is 50 into L is 44 into 10 to the power minus 3 ohm, right? And we need IRMS. So it will be VRMS divided by XL. VRMS is 220 divided by this 2 into 3.14 multiplied by 50 multiplied by 44, and let's write this 10 power minus 3 in numerator. So this will become 1, 2, 3. Correct? From here, this 0 will cancel out, and this 5 2s are 10. So this 10 will also cancel out. So what is left? It will be 220 divided by 3.14. So let's write here 100 to remove decimal. 314 into 4. Now let's simplify. So try it. So it will be around 15.9 ampere. Correct? So our question was, a 44 millihenry inductor is connected to 220 volt 50 hertz AC supply. Determine the RMS value of the current in the circuit. Right? So let's go to next point. Next is question number 7.4. So 7.4, what does it say? It says a 60 microfarad capacitor. So C is given 60 into 10 to the power minus 6 farad. A 60 microfarad capacitor is connected to 110 volt supply and frequency is given as 60 hertz. Right? Determine the RMS value of the current in the circuit. IRMS is to be found and this will be VRMS, right? VRMS. So to get IRMS, what do we need? IRMS will be VRMS divided by XC, right? And if you remember, XC is given by 1 upon 2 pi FC, right? So this will become VRMS divided by 1 upon 2 pi FC or VRMS multiplied by 2 pi F and C. Let's put the values. So if we put the values, VRMS is 110 into 2 into 3.14 into frequency is given as 60 and value of capacitance is given 60 into 10 to the power minus 6. Let's simplify. So here 1, 2, 3 zeros will cancel out. This 0, this 0, this 0. Then this will become 10 to the power minus 3, right? So let's write it further. 11 into 2 into 3.14 into 6 into 6 divided by 1000, right? So let's multiply. Give 1 minute to solve it. It will come out to be 2.49 ampere, right? You have understood? Now let's see next question. Next question says, in exercise 7.3 and 7.4, what is the net power absorbed by circuit over a complete cycle? Explain your answer. So here they are asking that suppose you have a circuit in which there is inductor and this is AC circuit. You have to find out what is total power consumed in one cycle. So for that purpose, we have to write the equations. Voltage equation is V0 sine omega t and current equation for L is minus I0. It is not sine, minus I0 cos omega t, right? If we find average power, so we can say Vi average and V is V0 I0 and from here sine omega t into cos omega t, and here I have left minus sign, or you can write here minus sign, that does not matter. So V0 I0 outside, then we are left with sine omega t cos omega t, right? So we can divide and multiply by 2. So V0 I0 divided by 2 here 2 sine omega t into cos omega t, right? If you remember the formula 2 sine theta cos theta, that becomes sine 2 theta. So this becomes V0 I0 divided by 2 times sine 2 omega t. Its average value. Here, if you observe this complete cycle, this is positive, this is negative, this is sine curve. So average value for the whole cycle will be 0. And this will be true for fx equal to sine nx. N can be any number 1, 2, 3, 4. So here this number is 2, n equal to 2, right? So its value will be 0. So we will get average consumed by an average power consumed by an inductor in AC circuit will be 0. Similarly, for a capacitor, let's calculate what is average power consumed. So we are considering a circuit in which there is a capacitor and this is AC source. If you remember, voltage across applied voltage is V0 sine omega t, and equation of current we have already derived. So I equal to I0 cos omega t, right? In this case, current leads voltage by pi by 2, that you know. Now here our concern is to find average power. So average power will be VI average. We put the values. So V0, I0 sine omega t cos omega t, cos omega t average. In same way, we can write V0 I0 divided by 2 times twice of sine omega t cos omega t, right? So this will become V0 I0 divided by 2 into, this will become average value of sine 2 omega t. And recently we have seen that average value of sine n omega t for complete cycle becomes 0. So this will become 0. So what do we get? So we have got that for complete cycle, power consumed in case of capacitor or inductor is 0. So that is answer to question number 7.5. Now we are going to see next question. Next question says, a charged 30 microfarad capacitor is connected to a 27 millihenry inductor. What is the angular frequency of free oscillations of the circuit? So here, angular frequency we have to find out. If you remember, we have derived the condition for resonant frequency xc equal to xl. In that case, we write 2 pi fc is equal to 2 pi fl. From here, if we want to find out angular frequency, so in case of 2 pi f, or in place of 2 pi f, we can write omega. So we write it omega c equal to omega L, which gives omega square equal to 1 upon LC, or omega equal to 1 upon root LC, or 1 upon root of L. What is L here? It is 27 into 10 to the power minus 3 multiplied by C is 30. 30 into 10 to the power minus 6. Right? So what will it become? Let's simplify further. Total power is 10 power minus 9. So we can do one thing. Here this value 30 into 10 power minus 6, second value is 27 millihenry. So both values we have written. So nothing is wrong. This will become omega equal to, from here we can do one thing. We can write it like 1 upon, we make it 2.7. 2.7 into 30 into 10 to the power, here this is 2.7 means 10 power minus 2, and this minus 6, 10 power minus 8 with under root, right? Now further this will become, we take it in numerator with the square root, this will become 10 power 4. So here omega equal to 10 power 4 divided by a root of 30 multiplied by 2.7. Now we evaluate it. So give 1 minute to evaluate it. So it will come out to be around 1100 radian per second. Correct? Is it simple? Yes, you can easily do. Now we are going to see next question. Next question says, a series LCR with R equal to 20 ohm. Let's draw the circuit. Here this is a circuit is LCR, so let's write them in order. Here this is inductor L, then there is capacitor, and then there is a resistor, and then there is AC source. So this is C, this is R. Values are given. R is 20 ohm and L is 1.5 Henry, 1.5 Henry, and C is 35 microfarad, and applied voltage is 200 volt. 200 volt, correct? Now, when the frequency of supply equals the natural frequency of the circuit, what is average power transfer to the circuit in complete cycle? So here this condition, when the frequency of the supply equals the natural frequency of the circuit, it means resonant condition they are talking about, right? So if they are talking about resonant condition, it means we have to find out resonant frequency, and if you remember, resonant frequency is equal to 1 upon 2 pi root LC. This is from the concept XL minus XC becomes 0, or XL equal to XC, and then we write value. This XL is 2 pi FL, this is 1 upon 2 pi FC, right? From there we get this result. So here they are saying that when the frequency of the supply equals the natural frequency, it means this is the condition. So this will be the frequency, but our concern is not to find the frequency. Our concern is what is the average power transferred to the circuit in one complete cycle. So in such case, if you remember, then total resistance will be what? In that case, resistance here R square plus XL minus XC whole square under root is impedance Z. But since XL minus XC becomes 0, so Z will be just R, right? And power consumed will be equivalent to a circuit AC circuit containing resistance only. So resistance is given, voltage is given, so we can evaluate. So let's try to find out the value. So power consumed, P will be equal to Vrms into IRMS, correct? So Vrms is given as 200 into IRMS will be 200 divided by resistance 20, and then this 10 times, so it will be 2000 watt, correct? Now let's see next question. Next question says figure 7.17 shows a series LCR circuit. You are given LCR circuit. So here suppose this is voltage source, and here there is inductor L, then C, and then resistor R. You are given this circuit, right, in which values are given. Supply voltage is 230 volt and L is 5 Henry, C is 80 into 10 to the power minus 6 farad, and resistance is 40 ohm, right? What is to be found? Determine the source frequency which drives the circuit in resonance. So again we have to find out same F. So here we can evaluate in terms of angular frequency, that will be easier. So omega equal to 1 upon root LC. We can put the values 1 upon root of L. What is L? L is 5 and C is 80 into 10 to the power minus 6, right? So minus 6 will go in numerator, this will become 1000, and here inside root it will be 400, which will give 20. So it will be 50 radian per second, right? So we have got the angular frequency. Then second point is obtain the impedance of the circuit and amplitude of the current at resonating frequency. So we have to find out the amplitude of current. For that we need impedance. So impedance, generally if it is not a resonant condition, in that case impedance will be given by Z equal to root of R square plus XL minus XC whole square. Since we are talking about resonant condition, so this term will become 0. So we will get Z equal to R. Now amplitude of current at the resonating frequency. So we have to find out I0. I0 is V0 divided by Z, and V0 in our question here, this is 230 volt. So this is RMS value. So we can write Vrms multiplied by root 2 divided by Z. Z is just R. So Vrms means 230 multiplied by root 2 divided by R is equal to 40 ohm. Now simplify, put root 2 equal to 1.42 and find out the value. So it will become 8.1 ampere. That will be peak value of current. Now suppose we want to find out IRMS. In that case, we will take just 230. This root 2 will not be there. Just VRMS divided by R is upon 40. That is 23 by 4 ampere. Right. Now next point is we have to determine resonant frequency, obtain the impedance of the circuit we have done, and then amplitude of the current at the resonant frequency we have got. Then last point is, what does it say? Last point says determine the RMS potential drop across the three elements of the circuit so that the potential drop across the LC combination is zero at the resonating frequency. This is also good condition, so we can easily do. So let's see what is happening. Now, so we have got the current. Now potential drop is to be found. So let's redraw the circuit. So here this is L, then there is C, and then there is, this is R, and this is AC source. We have to check the voltage. So here voltage will be VL. VL will be the current, RMS current into XL, right? So IRMS multiplied by 2 pi FL. We put the values. We have got the value of IRMS as 23 by 4 into 2 into 3.14 into frequency, resonant frequency. So we have evaluated 2 pi f. So we can write direct value. So if we go back and we find 2 pi f from that condition, means omega we have evaluated in previous case. So it is 50. So here 2, this is IRMS times, this is omega. So omega is 50 and L is given as 5. So we can find out the current will be 1437.5. 1437.5. No, this is not current, this is voltage, right? 37.5 volt. So this is voltage across inductor. We have got VL. Now we have to find out VC. So VC will be how much? VC is IRMS multiplied by XC. So IRMS 23 by 4 into XC means 1 upon 2 pi. 1 upon 2 pi, instead of 1 upon 2 pi, we can write omega C. So here this will become 1 upon omega. Omega is 50 and C is given 80 microfarad. So 80 and 10 power minus 6 we can write here as 10 power 6. Then again we will get 1437.5 volt. If you remember, I told you that voltage across inductor is 180 degree out of phase to voltage across capacitor, right? So if capacitor voltage is like this, then inductor voltage will be like this. Since both have same values, so they will get cancelled. Now third point is voltage across R. So let's find out. So VR is equal to IRMS multiplied by R. 23 by 4 multiplied by what is R? 40. This will be 230 volt. This will be equal to applied voltage. So you have understood how to solve these questions. Thank you for watching. Team Educate.